Good morning, everybody, and welcome back to Next Door NetAdmin. You would be forgiven if you've been watching this channel for a little bit of time and had the question, why is this guy calling himself the Next Door NetAdmin? Most of what he talks about is server admin level stuff. So why is it Next Door NetAdmin? That's a fair point. Most of what I've talked about on this channel so far has been server admin stuff that you would work on. But I am a network engineer, that's my job title, and I consider myself a network admin because networking actually is my strongest suit. That's what I do and I have a knack for. But so far, I haven't talked a whole lot on the networking side of things because that tends to be a little more complicated. Not really. I don't find it complicated, honestly, but that's me, and I'm a network admin. There's lots of numbers and math and complexity that, if I'm entirely honest, I haven't quite figured out how to discuss in a YouTube format, mainly because I have a day job, I have lots of other stuff going on, and I don't know video editing very well. So I don't have the kind of ability to put up fancy graphics and illustrate things the way that I would like to, except with my hands, which I do use a lot. That being said, I thought that I would actually discuss something network related for a change today. And I'm going to discuss this as sort of what I would consider a foundation for more in-depth networking discussions. I'm going to talk about network layers. And specifically, I'm going to use the OSI network layer model. This is a deliberate choice. We'll get into that. I say this is foundational. It's not like you're going to use this day to day. At least I wouldn't expect that you'd use it day to day. This is more of an underpinning for what you encounter later on. And I also do find it useful if I have a networking problem that I'm just not solving in the usual time. We all have our tricks and, first things we check. Oh, something's not working. Oh, well, just go check this thing. Yeah, I mean, those kinds of heuristic shortcuts that we use are completely valid. But it helps also if you're facing a situation that doesn't meet those heuristics, it doesn't meet those shortcuts. It's useful to have the foundation to say, okay, if I step through this one layer at a time, where is the problem? And I can focus my effort on the spot that's having the problem and not worry about the other stuff because either it's not relevant, I haven't gotten there yet, or it works and therefore I don't need to waste my time on it. That would be great. So, you may have noticed the title of this video is something that looks completely odd because it doesn't say anything tech related whatsoever. Well, this is a mnemonic. There are lots of mnemonics for the OSI network layer model that we're going to walk through, but the mnemonic that I have chosen to use in today's video is a penguin said that nobody drinks Pepsi. What is this? Well, this is the OSI network layer stack from layer 7 to layer 1. And I'm very deliberate in doing it this way because the higher stack levels are the ones that are closer to the user. And then as you go down the stack, you get closer and closer to the actual physical medium. The layers here, remembering that our mnemonic is a penguin said that nobody drinks Pepsi, our layers are application at layer 7, presentation, layer 6, session, layer 5, transport, layer 4, network, layer 3, data link, layer 2, and physical, layer 1. Okay, that sounds cool. All right, fine. Before we get too much further into it, and I'm going to discuss this in depth, I would like to acknowledge that there are other network layer models out there. For example, the TCP/IP network layering model is similar, and in some ways, people might argue that it's more practical because it conforms more closely to how people experience and work with a network on a daily basis. Be that as it may, I'm going to walk through the OSI layer model because it's a little bit more fine-grained. TCP/IP layer model only has 4 layers. Okay, cool. OSI has 7. So it takes, for example, TCP/IP, the topmost layer is actually the top 3 of the OSI model. So if I break that down a little bit more, I can be a little more fine-grained in my troubleshooting. That's just me, and it's partly down to how I was taught. If you're taught something different, that's perfectly valid. If you use something different in day-to-day networking, that's also perfectly valid. Again, this is just something that I normally use for troubleshooting and as a foundation to underpin my understanding of the rest of the network and how it functions. If we go through these layers in order from 1 to 7, so we're going to reverse our direction and start with Pepsi in this case. Physical. What is the physical layer? Well, the physical layer is, broadly speaking, just the physical layer. It's the cables, the actual wiring of the network, or it could also be the radio waves that carry the network information between access point and client workstation. The physical layer covers a lot of very, very heavy, dense math and other information that, quite honestly, I do not consider myself an expert on, and I honestly don't need to get into on a regular basis. I do not need to get into what voltage is on the individual wires, what is the bit wave signaling pattern. In radio waves, am I using orthogonal frequency division multiplexing? I probably am. Could I explain it to you? No, I could not. There's a lot of the engineering on the physical layer which we can abstract completely as network administrators in most cases. And for the purposes of this discussion, we're going to. Second layer, the data link layer, or according to our mnemonic, drinks. Data link is where we find things like MAC addresses, where we have Ethernet frames as an Ethernet protocol. There are other layer 2 technologies that could be in use other than Ethernet. Token ring is an example of that. But most of the time what you'll be dealing with is Ethernet or Ethernet based. So for the purposes of this discussion, we can abstract that to Ethernet. Ethernet is I can never remember if it's CS-CDMA or CD-CSMA. But it is carrier detect, collision sense, multiple access. I know these things, but sometimes I have a little bit of trouble pulling them out of my head. So carrier detect, collision sense, multiple access, CD-CSMA. And what this means is that you've got a fundamentally shared medium, and when one station broadcasts onto the network segment, It also listens to see if somebody else is talking at the same time. And if it senses a collision, then they both have to back off. This is a very, very, very old understanding of how Ethernet worked, because Ethernet used to have a bus architecture. Everybody was on the same segment. These days we have switches instead of hubs. Switches essentially break this bus architecture up so that only one station is on each cable. And it speeds things up dramatically. So while I'm talking about Ethernet in a more historical sense as a bus architecture, keep in mind, in most cases, you're not going to encounter that anymore because we've moved past that. We're so advanced. But layer 2 is where you have the actual data link, the structure of Ethernet itself. You have address resolution protocol to determine MAC addresses. You have CDP, or Cisco Discovery Protocol. You have LLDP, or the generic link layer discovery protocol. These things all work on layer 2. And so if they're not working, you've got a layer 2 issue or a layer 1 issue. Layer 3, the network layer. Nobody. The network layer is where we find Internet Protocol, or IP. We also find its companion, the Internet Control Messaging Protocol, I think is what that is. ICMP. It's the protocol that gives us ping. Ping uses an ICMP echo request message, and then you get the ICMP echo reply messages. These work at layer 3. So this is where you get IP addresses or other network layer addresses. If you're using the old Novell IPX SPX protocol, which is Internet Working Packet Exchange, and I don't remember what SPX stands for, you'll have to look that up. IPX SPX used different style addresses, but it ran at layer 3 of the OSI networking model. You could use other networking layer protocols such as AppleTalk. Those might have different addresses as well. I don't know, I'm not a Mac guy. But for the most part, IP has become the standard, and so you'll see IP addresses all over the place, and it's very standard to work with. If you can ping an IP address, then automatically that tells you layer 3 is working. Layer 2 is working as well, because the way this works is you go from application all the way down to physical, and then you transmit, and then on the other side you go all the way from physical back up to application. So if you can communicate on layer 3, that means that layer 3 and everything below it, layer 2 and layer 1, is working. Cool. If you can't ping, on the other hand, then there's no point in trying to troubleshoot something else like, oh, I wonder if it's DNS, or I wonder if the web server is down. If you can't ping, then your problem is at layer 3 or lower, and there's no point troubleshooting further up the stack. So ping is a very normal, I would say, a very normal tool to be using to just verify, do I have layer 3 connectivity? Yes, no, cool. Go from there. Layer 4, transport layer. This is where we find TCP, Transmission Control Protocol, or UDP, the User Datagram Protocol. Again, this is from memory, so wiki it if you want to be sure that I'm saying the right words. TCP, UDP work on port numbers. And where I said Ethernet has frames and IP has packets, TCP works on segments. You'll have a segment of traffic that is then packaged by IP and into packets and then sent down to Ethernet and packaged into frames, and off it goes from there. But TCP and UDP is where you have port numbers. It's important to note that when you have an IP address with port number, you're actually mixing layer 3 and layer 4 addressing information. You've got a layer 3 address, the IP, and then a layer 4 address of the actual port number on that machine. And there are 65,500 and I want to say 36 ports. Everything from port 0 up to port 65,535. If I'm remembering that last two digits correctly. I know it's 65,500 something. Everything from 0 to port 1023 is reserved. Typically speaking, you will not be able to connect to it or set up something to serve that port unless it is the correct program or unless you are root and have the privilege to use those ports. The higher ports are called ephemeral ports. They're the ports that a computer opens up to send just regular, hey, I want a web page traffic. Okay, cool. Layer 5, the session layer, said. Session is where you find the concept of sockets. TCP and UDP will often open up a socket for applications to send traffic to. This exists at layer 5. Another protocol that exists natively at layer 5 is NetBIOS. NetBIOS is not commonly used these days, but it used to be a big thing in the Windows world in the days of Windows XP and older. And NetBIOS also allowed you to do some file sharing. Standard file sharing today, SMB, has its own protocol and everything else. That's fine. But if you were using file sharing over NetBIOS, that was directly a session protocol. Session is also understood as the layer where it's just concerned about keeping the endpoints open and continuously exchanging traffic between two systems. That's the session. Layer 6, presentation. Penguin. Presentation has to do with the format of the data that's being exchanged. In this case, we could think of it as character encoding. There's a few different ways of encoding characters, whether that's ASCII, EBCDIC. Yes, I know that was a lot of letters that I just read out. Don't worry about it. The format for a JPEG file, that exists at layer 6, the presentation layer. The MPEG format for video also exists at layer 6 because it's all about the format of the information that's being exchanged. Then you have layer 7, the application layer. In the example that I'm going to use, this would be something like your HTTP traffic, where you're actually talking to a web server and asking it for information and it's sending it back. Okay, what does this look like in practice? Okay, I connect to a web server and I'm going to look at the flow of the web server's response specifically. At layer 7, I am sending it text. I am sending it a text request. I would like to get / the root of the website. Okay. So it has that data. It has to encode that into text because it's a text response. Or if it includes JPEG files or anything else like that, it has to encode those into the relevant format for those files. So that's going from the layer 7 text request, I want this, and the server's response is 200, okay, and here's some data. Okay, 200, okay, that is text. When you go to application, how do I encode this? I'm going to put this into the ASCII character set, which is encoded like this into these values. Okay, then I'm going to pass it off to my TCP socket, which is at layer 5, the session layer. Then I'm going to put that over TCP port 80 because the server is running on port 80 and is responding from port 80. And I'm going to send it to port whatever the ephemeral port is on the requesting side. Okay. Then it goes down to layer 3, the network layer, and it says, okay, this is headed for IP address 192.168.1.10. Okay. And it's coming from 192.168.80.5. I don't know, I'm making this up. Then it goes down to the Ethernet layer, and it says, okay, well, what's my default gateway? Because that's on a different subnet. So I need the MAC address of the router. I need to use ARP to get address resolution for the MAC address of the router. Okay, now I can put that in the Ethernet frame. I pass it all the way down to the physical layer, and the network card sends it out over the wire or over the radio if we're using Wi-Fi. There's a lot of stuff going on here. Absolutely. If you can use ping to verify that your layer 3 connectivity is good between IP addresses, then you can start looking at the higher levels. You can say, okay, is my port open? If the port's open and we've got traffic between the ports, then I know that layer 4 is good. You might skip all the way ahead to layer 7, which is a valid consideration to make, and just query the web server directly. You can do this with telnet. Telnet as a protocol, much maligned, not very secure. It's not secure at all. Absolutely. But if you have a telnet client, a lot of internet protocols still fundamentally use text. So as long as you don't have to go through an encryption layer like HTTPS, which for most purposes you should be doing, but for troubleshooting, if you have regular HTTP, you can use telnet to go telnet to this address on port 80. You'll get a connection. And if you type get /, you should see a text response come back from the server with a status code, whether that's 200 OK, followed by data, followed by your HTTP page, or whether it is 404 not found, or 401 unauthorized, or whatever it responds with, you should see text come back. The same is true, incidentally, of SMTP. You can telnet to an address on port 25, and you should get an SMTP banner. You should be able to say, hello, and your host name, and the server should, say hello back. And then you can type in quit and abort the connection. If you can use telnet to get a connection to the application, then you know that everything is working correctly from layer 7 all the way down. This doesn't help you if you've got a problem at a lower layer, clearly. But what are some things that might happen at a lower level that would block that? Okay, then you start looking at, is the port open? If I can ping, but I can't get a telnet connection through, well, is the port open? Do I have the right address? Is the service located on a different server altogether? What are some things that can happen to block the communication that would not show up even if you have a layer 7 full connection? Well, what if it's a DNS issue? If you're doing telnet to an IP address, you're not doing address resolution, which is done through DNS. So you can confirm that you have a full layer 7 connection to the destination system, but the problem is something else entirely. So while this model is not the be-all and end-all, it's just a foundation to help you with your troubleshooting. Because if you can say I've got a problem at a particular network layer, then you can troubleshoot that. But the layer might need to be troubleshooted for various steps in the process, not just connecting to a server at an IP address, but also in DNS. Does my DNS request to the DNS server also go through this stack? Yes, it does, absolutely. Does it work? Maybe it does, maybe it doesn't. And then the most important question, do I get the right data back? Yes or no? Because you can have full connectivity working and still get garbage data if somebody's accidentally put something incorrect into the other side. So there's a lot of things that you can troubleshoot, but this hopefully gives you some more insight into the kinds of things that a network administrator keeps in mind while troubleshooting, and some of the things that you can do to troubleshoot it as well. I think that's more than enough for one sitting, so I'm going to let you all go for now and absorb that, think on it, maybe do some more research yourself, and I would highly encourage that. But for now, thank you very much for watching. I am your next door NetAdmin, and we'll see you next time.